In this complete session, we are going to learn about Python for Databricks. So before that, just few words about me. So this is my complete information. My name is Harish, and I'm doing as a senior technical lead for one of the biggest MNC. And I have overall 10 years of experience in development and in the system architecture design. Right. So you can contact me any of the social media, either on my personal wall of Facebook or my Facebook page or LinkedIn or on WhatsApp, anywhere you can join. Right. So agenda for this. So this complete training session will be into two levels. So, right. So what are the requirements and the result from this complete course? So the requirements are nothing, very basic things you only require. Those are, you have to have some basic knowledge about the system. So coming to the next one, business process. The next one is basic domain knowledge, and no requirement to what it is, no requirement to have the programming knowledge. So because we are going to start from zero level. Okay, the complete Python will take you to zero to hero. Right. So once the course is done, what you can gain from this? So the real-time experience. One is you can get that confidence. Right. So the confidence will make you to break the interview or to make you to make yourself, what it is, project yourself as a strong guy in the technology. Right. So these are the things. Now we are going to start with the first point in the level one. Right. So big data. We're not going in depth into the big data, but we're dealing with the big data, right? So we had to know what is big data, why this is. So might be people might ask you, people might talk about big data. So when we are talking about the big data, sometimes somehow it become as a technology into our brain, right? Somehow it flash. Big data is a technology. Actually, big data is not a technology. Big data is a term where it can explain and deals about the technology with its nature and its what I can say, volume of the data, right? It's a term which explains everything which we can deal with this one. So there's a simple definition what I kept here. Big data is a term that describes the large volume data, and the data might be both either structured or unstructured. Okay, so there's a way. So the complete big data contains 6 ways. Probably interviewers can ask you that 4 ways, but what about the remaining 2 ways? So these are open source availabilities, right? So the remaining 4 are stable for big data native. So these 4 will explain big data nature and big data, what it is, everything about big data. Okay, what are these 4 ways? The first thing is volume. Big data is nothing but 1,000 records or a million records. It might be billion, trillions of records. Okay, so the best example, while I'm working with one of the biggest MNC, that's a chip maker, right? So just imagine that chip maker, how much data they can generate while they are building the chip. Whenever they are running a while they're doing test runs with a complete grid, complete system, it will generate petabytes of data every time for each run. Imagine the same way how that army equipments will generate, how that satellites will generate the data. We cannot. These are high level. So when we are coming into our what it is, our limitations, just take a mobile phone, right? So we are using Google Maps there, right? So imagine if you are going to one place by using Google Maps, how much data it will generate to the Google server. Imagine at the same time, 1,000 members are using the same Google Maps to reach any point to any point, right? So imagine what will happen if the count will multiplies, what will happen? Data is nothing but whatever the data it generates, whatever the request it submits to the server, and whatever the response it gets back from the server is in GBs, right? That is about the volume. So big data will deals with the large scale of the volume, right? So the next thing, variety. So the data is not specific to the single variety of the data. I mean to say it's not single with SQL data, or it's not single thing with the text data. It might be into the different levels. The levels are nothing but, I mean, the acceptance criteria are nothing but anything. So it might be your regular form submissions, it might be SQL data, it might be regular voice, it might be text, it might be image, it might be video, it might be anything, either either source of sound form, visual form, or a content form, anything might be big data, right? So coming to the third V, that is nothing but velocity. So the velocity will deals about the speed. Okay, so the big data deals with a large scale of data, right? So the way it is generating the data, the way it should be respond back, right? So the generation of big data will be in the large scale because millions of requests will come into the system where millions of records will be generated or created in the database or data source, whatever it is, right? Either log or a database or error blocks or track systems, okay, or not anything, right? So in the same way, we had to respond in milliseconds back. So the speed consistency is nothing but just we can say the velocity, right? The fourth V is veracity. Veracity is nothing but guarantee, right? Um, how much we can believe, how much we can what it is sustain with the data. Okay, so that guarantee will come from veracity. I mean to say, unnecessary data is not required for the business, right? Whatever the data we are collecting, that should be more meaningful. Then big data is more useful here. If you are processing unnecessary data and collecting tiny part of the data is really not a good thing, right? So to make big data more efficient, there's four things we have to follow, and these four V's are only the key factors of big data, right? So remaining two, when interviewer asks you to explain the six V's of the big data, then you have to tell about the value and the variability. Okay, so value. Okay. So when it comes to the value, whatever the big data we have processed, we have defined with the four V's. Okay, so that big data, how much valuable to the business, that will explain by value. Okay. And the sixth V is variability. So the variability is nothing but how we can play with the data, right? We have processed, we have collected, the collected data has a value, but how we can use the data into our application is nothing but the variability, right? So these are the six V's of big data, which explains the nature of the big data and the functionality as well. So we said the big data is a term, right? Then what is the technology for big data? Hadoop is a one and biggest technology. One of the biggest, not it is one and only, is one of the biggest technology, right? Because Hadoop is open source and anyone can pull it, anyone can um, go with the Hadoop system, right? So we're not going in deep into the Hadoop, just I have given the overview here, right? And the next one, okay, we learn many things. I mean, we get some information about the Hadoop. Then what are the biggest problem? We know Hadoop has a lot of facilities. Hadoop has a lot of things inside it where it can process the large scale of data, right? But what is the biggest problem with Hadoop? The biggest problem with Hadoop is latency, right? You might be shocked. Hadoop is a technology where it helps to process data faster than anything. then how come the latency came here? That's nothing because of its IO problem. IO problem means, so every time when the process was started, when the process, transformation logic is executing, the problem here is it can pull the data from the database or a hard disk and then process it and write it back to the hard disk again, right? So that is the biggest problem there. So every time when we are pulling from the hard disk and when we are writing into the hard disk, there is a latency that is nothing but IO. IO is nothing but input output, right? Because hard disks are always slower than RAM, right? That's why it became a bit slower than the current technology, what we are going to learn in the next few slides, right? So this is what is happening here. You can see the slaves, the machines, which are processing the data actually, and which are pulling the data from database and write it back to the database again once it is done. And another machines and another process things are pulling the data from previous returns or fresh things again. So this is a complete thing. See, here we have 3 stages with 4 levels of data pulls and pushes, I mean to say reads and writes, right? So these 4 things will takes place for the latency, right? So then what is the solution for this IO problem? The Spark is a solution for the IO problem. How Spark provides a solution for it? So there is also a read and write for the solution, right? But how come? How come the read and writes? How come that input and outputs are happen on the hard disk, and how it is playing in middle, right? So you can see there's the same 3 stages with 4 levels of disk things, right? Disk readings. So the first level of disk will be, first level of the read will be happen from the disk, and at the end, once all process is done, it is going to write back to the disk. So in middle, it will never touch the disk, right? It will never touch the hard disk. It will keep everything inside the RAM, and it can play with. That's why when we are using Spark technology, the process is faster than anything. The process is uh, takes place in milliseconds, right? And also it is a bit uh, expensive because RAM is expensive than regular hard disk, right? So this is why it might be a little expensive, but it provides the 100 times accuracy, 100 times faster than the previous, right? Might be light expensive, but the accuracy is high, right? So that's how the Spark provides the solution. Okay, now we know where Spark helps in the big data, right? Now we are going to know about the Spark. So before this, we just learn about what is big data, how big data deals with, what kind of data big data technologies are doing, and what is the problem, and what is a solution for that problem. So now we are going to deal with our actual technology is Spark. Why? The Spark is a technology from big data, for big data, not from, for big data, right? So the Databricks as a GUI for this, what it is for Spark, right? Then why PySpark? PySpark is nothing but Python package which interacts with the Spark technology, right? So we are going to interact with Spark by using Python. That's where. So let's come into the Spark ecosystem. The Spark ecosystem is built with 3 modern layers. Those layers are nothing but PySpark core engine, which can deals with any of the technology within the 4. I mean to say Scala, Java, or Python, or R. I mean to say Erlang. So which can deals with any of the technology to interact with any of the data source. There's no limit which makes to which makes you to pull the data, right? You can pull the data from any of the source and you can process with that. Okay. By the way, this Spark, complete Spark tool is built on Scala language. This is completely different. And the Scala is more similar to Java, right? Because the Scala itself is also used the Java virtual machines, which can execute. It's a core logic layer, right? So that's why these two are more useful in that Scala. Okay, so but when it comes to the syntactical way, when it comes to the understanding the program, right, that these two are more complex. Also, Scala has a problem which doesn't have that much packages, that much flexibility in terms of dealing with what it is, machine learning data or any kind of artificial intelligence related process threads, right? So Java has that compatibility, but the way uh, we are writing the program in Java, the way it makes complex, right? That's why these two are a bit complex. Then what are the simple solutions to make the program easier? The first choice is Python, which is capable to do anything, right? And the second one is R. R is capable to anything with the data, but not with other levels of programming, right? That's why R comes into the last place, right? So the core engine is capable to communicate any of the data source to pull the data into um, its native layer and then process the data with RDD API. RDD is nothing but resilient distributed data. Resilient in the sense it's a native formatted of processable, progressible, and invocable data in a simple manner. So there is a big explanation for that. So when we are going into that level, we can come to know about this RDD more. Okay, then what are the different featured layers on top of this RDD in the Spark? So the thing is Spark SQL. So we're dealing with Hive or any of the SQL or a structured data with this SQL, right? And the next thing is streaming. So streaming is nothing but dealing with live data is the biggest thing, biggest required thing in a big data. Because when you are using Google Maps, right, it is not supposed to be take that much time to tell you how much time you can how much time it takes to reach the point. It will never take the much time to explain you what is a traffic update on the route, right? It should be in milliseconds. Then only that application is useful. Otherwise, that is not useful, right? So imagine in the same way. So some application is going to generate the data, just like simulations, right? Just like health domain, right? Just like biochemistry, which helps to generate the medicines, which helps to produce the medicines for health, right? So how much speed it required, right? So it will take the data, it will process on time, and then it can respond. That's a requirement. That's a simulation requirement, right? So in that places, Spark streaming will help a lot, right? Next, so mlib is nothing but machine learning library. So this helps you to build that machine learning models, right? To train the system to get the accuracy from the training model, we can use this mlib. And the graphics, it will helps you to generate the graphs from the data, right? Graphical representation, I mean to say that, right? The next one is, as I said, it has its own packages for different languages, right? So for Python, for Scala, for R, the Spark itself has its own packages for that. The biggest package is nothing but PySpark, right? So this is about the Spark ecosystem for big data. So the next one is execution in Spark. How that execution happen in Spark? Okay, we know it has a different ecosystem. We know it has a different process to solve the IO problem, but how the execution takes place inside the Spark, right? So the Spark is continuously goes with clusters, right? So the clusters are nothing but a combination of two things. That is the master and slave nodes. Okay, what are these two nodes? What is a master node and what are the slave nodes? So in any of the cluster, there is only one master and n number of slaves will be there. The master is responsible to remember the slave addresses and the jobs, what it is scheduling on the slaves. And the master is only responsible to schedule the jobs and collect the result from the jobs from slaves. And then coming to the slave nodes are nothing but actual process machines. Okay, as I said, Spark is using Java virtual machines, right? So these nodes are generated either physical system or a virtual machine, yeah, with the help of virtual machine, right? Anything, the machine will appears there. It can come up with a use RAM, and the node has a capability to catch the data into its own native place. It can process the task and respond back to the main what it is master node. So the master node is nothing but a driver program, or there is one thing, master node or a driver node, right? So this is the main thing. And when it comes to the slave nodes, we can say either it is a slave node or worker node. We can see what are these, how this will come in the actual clustering. While we are going to create the cluster, we can see that. So how the shake hand will happen in between. See, this is a simple result, simple diagram which can explain the shake hand, right? So master can send the task and get the result. The slave is responsible to hold the data, cache the data, and it can process the data and place into the disk and return back. Okay, when I said disk, it is not only the native disk. Of course, it might not contain anything in the native disk. It can send back to the source where we want to store the data actually. It might be any of the database program or any of the data warehouse systems, right? Because it's already become as a structured data with the help of transformation. That's what it is happening on any of the slave. So the limitation for this is infinite. Any of the cluster might contain only one master, but not limited for slaves. You can keep a number of slaves based on your requirement. Okay, but you have to be aware of the budget concept. So if the budget exceeds, obviously the technology will collapse. Right? We have to care about that. Then why to use Spark? Okay, so we have data warehouses in what it is traditional manner. Later, Hadoop comes with map reducers, right? So map reduce is nothing but just pull the data map with the actual processor and reduces back to the, uh, reduce the data by restructuring it, right? So we have advanced technology that is called Spark instead of this map reduce. Okay, so why Spark is more familiar, more flexible in big data. So here we have all the things, the key factors. The warehouse is capable to do SQL optimization and data modeling and catalogs and asset transactions. Asset transaction is nothing but is a two-way, what it is, two-way transactions which can write the data, which can secure the data, which can makes the data can be available on demand, right? So these three are capable with data warehouse, but the separate computation storage is not there. Okay, more than SQL. So SQL is nothing but place, execute some structures, some kind of statements on a SQL platform to pull the data. But it is not enough for the machine learning. It is not enough for the on-time, real-time data speculations, right? And it is not also open source. Of course, we have some open sources right now, but it is not 100% open source. Okay, there are communities. Communities have lag in some dimensions. You have to what it is. You have to be aware on that. Otherwise, you might lose some things, some security with the community versions, right? So then what Hadoop will do, right? Hadoop will play with the first three, but not with the next three, right? It is not having SQL things and data model catalogs and that is, ACID transactions, but it has a capable to separate computation process, mean to say parallel processing. We can split the task and process the same task in multiple machines. Okay, so just a small explanation for that. So we have million records, just take 1,000 records for now. So we can use a single computer, which is a medium level of what it is equipped, mean to say with a 16 GB RAM with dual core or i3 processor, okay, with acceptable 512 GB RAM, right? So imagine that that the single machine takes approximately 1 hour to process the data. Just imagine. It is not accurate, but I'm saying 1 hour. 1 hour to process that 1,000 records, right? If you take the parallel process to split the data and share that the parts for two machines, the time will reduce half, right? So if you reduce into the n parts and hand over it to the n machines, it will be processed in a second, right? So that's the biggest technology of uh, what it is, parallel processing or a separate computation, right? So just Hadoop has this feature, and it can capable to serve for the machine learnings, right? It can capable to stay on the open source, right? But it has no things here. Just to say that it is not much capable to operate the SQL operations. It is not much capable to build models. Data reshapings and all the stuff. So we had to use other tools to make it. So by combining these two, we can achieve this all. But we have a solution that is Spark, which can come up with all, right? So the Spark is capable to do anything. Okay. To make that ACID transactions, we have Delta Lake. Delta Lake is nothing but a reliable layer which makes perfect actions on ACID transaction, right? So that is about the Spark. That is the biggest advantage with the Spark. Then what is this 3? This is nothing but a just recent stable version of Spark. There might be different versions in the market. We have to rely on that, the stable versions. Okay, those are called LTS, long-term stable softwares. Okay, also known as long-time stable applications. Now, boom. So earlier, till previous slide, we come to know the technology um, about the big data and the tools what we are using there, right? Now, we are going to play with Python inside Spark, right? So that is nothing but PySpark. Python plus Spark is nothing but PySpark. So we had to know the Python and also we had to know the Spark. That's what we did till now. So in the next class onwards, we are going to play with the Python. So once we are familiar with Python, then we are going to play with PySpark, right? So what PySpark will do? PySpark is fully loaded with all the features what Spark is having because it built for Spark in Python, right? That's the biggest thing here. So whatever it is doing, in-memory computation, lazy evaluation, fault tolerance. What is fault tolerance? So I haven't explained this fault tolerance in what it is in any of the previous slide, right? Fault tolerance is nothing but less error. So while it is processing, something will happen. Somehow the slave machine is not responding, or some error was happened. What will happen? Master is responsible to reprocess the job in any other machine to get that accurate data instead of giving the error. So that means less error. That's why they can give the guarantee. Somehow people come to say 99.9% uptime, 99.9% reliable data, 99.9% it can give the guarantee, right? How come? Based on this fault tolerance, maintaining the fault tolerance, right? Immutable. Immutability is nothing but whatever the data we get from the data source, we can make that update. We can change the data. We can play with the data like anything, right? So that's one. And partitioning, right? So how the data will be partitioned, how we can split the data, how we can split the big data into the smaller chunks to go with the parallel computation, right? And the persistence, how can you persist, right? How can you rely on that one? How can you give the guarantee for the machine learning libraries? Of course, we are not going to learn the machine learning libraries here. That's again complete different what it is, a different technology. But we're going to know how it is. Okay, and cross-grind operations mean to say it can do what we can say that the delta legs, right? So such kind of operations also it can do here. Mean to say it can do same kind of operations or different kind of operations. So simple example, it can pull data from one platform and then transform the data into the another structure and place it into the another place. Or it can pull the data from other slave, whatever other slave processed and return back to the master, and it can apply other logics on top of the data and place it somewhere else, right? These are nothing but class grinds, right? These all technologies, all features are also available in Spark because PySpark is built for Spark, right? The biggest advantage here is PySpark deals with Spark through P4J, Python for Java, right? That's a background technology. We're not going to deal with that, but we have to be aware because sometimes interviewer definitely ask you to confuse how the Python deals with Spark internal layer, Spark core layer. Okay, Python, PySpark is built with Python to play in Python for Spark, but the PySpark can communicate through P4J module, right? Now, till here we know about Python, PySpark and Spark. Then what is Databricks? Okay, just a basic thing. Databricks is nothing but UI for Spark. So the Spark guys only build this Databricks to make the Spark technology should be available with graphical user interface to create the clusters, to create the notebooks, to create the jobs, to build to build on Sarudat, what it is, machine learning libraries and everything, right? To play with the data, to do anything, they build this UI for Spark as Databricks, right? So this UI can facilitate to survive the Spark technology with GUI in any of the cloud platform. So you can go with Azure, that is called as Azure Databricks. If you go with AWS, that is come as AWS Databricks. If you go with GCP, that is come with other name. I'm not sure with what it is. Of course, I believe it is same as Databricks again, but I don't know actually. Any of the cloud can easily access, right? So this is what. And when we are using Azure or AWS Databricks, that should be payable, that should be chargeable. You have to be aware of that. So for learning purpose, for practice purpose, we're not going to take that expensive thing. We're going to use the community version of Databricks, which helps you to familiar with Databricks. So later point, once we are familiar with the Databricks UI and Databricks technologies and all the things, Databricks technologies, then we are going into the cloud to play with one or two classes, right? And the flow inside the Databricks. till here we know what is the Databricks and what behind the Databricks, right? So when it comes to the Azure Databricks or any cloud Databricks, so here the people, in the sense who require to play with the data, they will come into the Databricks and they can do whatever they want here, and they can supply the data for other applications. Okay, so what they can do inside the Databricks, they can create the workspaces where they are actually going to work for specific tasks, right? And the workflows are nothing but the steps or techniques to transform the data, right? Databricks runtime, you have to be remembered this. The runtime is nothing but the computation engine. Interviewer might ask you, explain me about the computation in Slack, or they might ask you, explain me the runtime about Databricks or computation process in the Databricks. So all these are nothing but clusters, right? The cluster is nothing but a computation engine to execute the data flows and give the output, right? So we have to be aware of this. And the next one is nothing but IO. Okay, DBIO we call it. DBIO is nothing but Databricks input output. As I said, right? It can read the files from disk, it can process in memory, and then it can write back to the drive, right? That is nothing but DBIO. We are going to deal with this one. Okay. Also, we are going to plug any of the any of the data sources to pull the data. Okay, and it has a facility called serverless. Serverless is nothing but you are not supposed to keep a server to run this Spark. You are not supposed to keep a physical server or virtual server, anything. So it can generate its own clusters, its own architecture on demand. Once the process is done, it can destroy that. So this is nothing but cost efficiency. We are not going to deal with this one because this is 99% DevOps team or administrator thing. Okay, we are not the administrators. Okay, so administrator only can take, I mean, only can play with this, or a DevOps man, right? Who are going to create the jobs, who are going to what it is, fire up the jobs on demand on a schedule base. Okay, that is nothing but serverless. That deals about the serverless. Sorry. So next, the final thing is nothing but a security system. Okay, PySpark, I mean, to deal with PySpark, when we are going with the community edition, we don't have security, as I said earlier. We don't have much security here. But when it goes with enterprise, I mean to say paid versions, they will provide you enterprise security. Okay, Databricks come up with enterprise security, which can prevent data losses and which can prevent unauthorized accesses, right? So these all can come up with Databricks enterprise security. Okay, so we're coming to know all these things except serverless because it's a DevOps thing, right? So again, the way when they are when the people who are having the requirement with the data, when they come up with, they can do all this process by utilizing all these resources. Of course, these are not enough, but I can say these are now, right? And then they can transform the data into any of the application for use case, right? This is nothing but the workflow inside what it is, Databricks, right? Yeah. So till here, the theory part is done. I mean to say the first three, and the next thing, what we are going to learn in the next classes. Okay. So first thing is how to set up the application. I mean Python and its IDEs and configuring them and execute the first code, first program in that. Okay, with the multiple things, and then we can confirm that the application is ready, or the Python platform is ready for us to program, right? And then the next thing is, once we are done with that one, we can deal with basic concepts of the program. What is basic, what is a programming, how a program can deal with the what it is, statements and all the stuff, right? Executions. And then once we are done with the four things, we're going to start the core Python actually, right? So there's agenda for the next.